Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we are looking at this very interesting topic, differential calculus. Let's look at the concept of calculus, the concept of differential calculus. This calculus is being classified into two categories, that is integration and differentiation. In today's lesson, we'll be looking at the concept of differential calculus, the concept of calculus, as well as the method of differentiation. Let's start with the concept of differential calculus. Differential calculus uh, differential calculus deals with finding out the rate of change, the rate of change in certain quantities with the slopes of curves. Differential calculus deals with finding out the rate of change in certain quantities with the slope of curve. Calculus itself is a branch of mathematics that deals with change. Calculus is a branch of mathematics that deals with change. This calculus is being classified into two categories, integration and differentiation. In today's lesson, we'll be looking at only differentiation. We'll look at methods of differentiation. Very important. Uh, as I said, this calculus is being classified into differentiation and integration. Let's look at uh, method of differentiation. Method of differentiation, very important. Methods of differentiation. We're looking at differentiation, but under differentiation, we'll be looking at the method of differentiation. Differentiation. Then we are looking at methods, or they call it rules of differentiation or method of differentiation. They mean the same thing, method or rules of differentiation. I have basically six methods of differentiation. Number one is what we call the general method. We have the general methods of differentiation. Very important. Number two, we have differentiation from first principle. Differentiation from first principle. Then number three rather, we have what we call chain rule. That is functions of a function of a functions. Very important. Then number four, we have what we call product rule. Product rule of differentiation. And number five, we have what we call quotient rule or methods of differentiation, either quotient rule or product rule or method of differentiation. Then number six, we have the implicit differentiation. Differentiation, very important. Implicit differentiation. So we'll consider only the general method in this presentation. We'll pick just the general method and look at it. In our next presentation, we pick differentiation from first principle. Let's consider general method. Before I claim this, we establish the fact that differential calculus deals with finding out the rate of change in certain quantities with the slope of the curve. Calculus itself is a branch of mathematics that deals with change. Very important. This calculus is being classified into two categories, that is differentiation and integration. Let's consider the general method now. Permit me to clean this side. Let's consider the general method of differentiation. Uh, we have the general methods of differentiation. General method of differentiation. Very important. Uh, if y is equals to x power m, it means if we find the derivative of this function, another name for differentiation is the derivative of a function. If you find the derivative of this function, or if we find the y by the x, or y prime, or y prime, or f prime, or m, which is the slope of this function, what are we going to get? Very important. In other words, we can use the general method to find the derivative of this function. Since x is a function of y, it means the y by the x now, which is the general method now, will be this n will come up, this n will come down and multiply this x. We have n times x, this power n will reduce by 1. So the y by the x now will say to be n multiplied by x power n minus 1. And this is said to be the general method of differentiation. Very important. This is said to be the general method of differentiation. We can either use first derivatives or dy by dx, y prime, f prime, or m. They mean the same thing. Very important. Let's look at example. Suppose we are asked to find the derivative of this function. Example 1 now. Let's say e.g. 1, we are asked to find the derivatives. The derivative means differentiation. We are asked to differentiate, or we are asked to find dy by dx. Find the derivative of y equals to 3x cubed. Let's say this is a, or let me leave it as b. We are asked to find the derivative of this function. And of course, this is a cubic function. So to find the derivative means we are asked to find the rate at which y will change with respect to x. In other words, the derivative of this function means increase in y as x increases, or decrease in y as x decreases. Very important. So dy by dx now will be, we apply this, if we consider this 3x here is our x. So this 3, which is our n now, will come down to multiply this. We'll have 3 multiplied by 3x. The power 3 will reduce by 1. Very important. So we have dy by dx now will be 3 times 3 is 9x. 3 minus 1, of course, is 2. So this is said to be the derivative of this function. Let's look at another example. Example 2 now. E.g. 2. Suppose we are asked to find dy by dx of y equals to 2x cubed plus 4x squared minus 5x plus 6. We are asked to find the derivative of this cubic function. Under rules of differentiation, the derivative of a constant is 0, like the derivative of this 6 is 0. So let's apply the general method. Very important. Changing y now with respect to x will be, this 3 will drop down to multiply this 2. 3 times 2 is 6. The power, of course, will reduce by 1. Reduce 3 by 1, we have 2. Plus, we do the same. This 2 will multiply this 4. That will be 8x. This power 2 will reduce by 1. We have power 1. Minus, this x has a power of 1 now. We reduce this one will come and multiply 5. We have 5. Then we have x minus 1. X power 1 minus 1. Derivative of this constant 6 is 0. Very important. So dy by dx now will be 6x squared plus 8x minus x power 0 is 1. 1 times 5 is 5. So this is said to be the derivative of this cubic function. We can solve as many questions as we can using this general method of differentiation. Thank you for watching. Please do share this to your learned colleagues and don't forget to subscribe to TJ Smart Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. In my next video, God's willing, we look at differentiation from first principle. Thank you for watching.